ISI, INR and MNPT are three numbers that are very important in the standardization of PT results. This is because the thromboplastin reagent used for PT estimation is very variable in its strength. PT is a test that needs continuity. A patient on anticoagulants will need repeated estimations of PT. So, the variability within the same lab and between labs has to be minimized. What is an ideal thromboplastin? It will be the same as the standard PT reagent established by WHO. Since in real practice this is not possible, two corrective steps are undertaken. 1. Each batch of thromboplastin reagent is calibrated against the standard PT reagent established by the WHO, and this value is called the ISI or the International Sensitivity Index. The ISI value has to be assigned by the manufacturer for each lot of reagent. The lower the ISI, the more sensitive the reagent. ISI value of 1.8 to 2.4 has low sensitivity. ISI value of 1.4 to 1.8 will have average sensitivity. An ISI 1.0 to 1.4 will have high sensitivity. Always understand the ISI value whenever you get a new lot of PT reagent. Search for the ISI value on the kit insert. For the kit used in this demonstration, the value is 1.6. Some kits can specify multiple ISI values. This is because the reagent needs to be calibrated for different equipments. 2. INR or International Normalized Ratio. Every lot of thromboplastin is also required to have a population mean derived from the normal population. For this, an estimation of MNPT or mean normal prothrombin time is required. A laboratory can estimate the MNPT from a minimum of 20 healthy individuals with a relatively equal mix of both sexes over a range of age groups. People on anticoagulants, pregnant women, people with known bleeding tendencies should be avoided. Estimation of a geometric mean is to be preferred to the arithmetic mean. MNPT samples must be fresh. The mean of a laboratory normal control is not an acceptable substitute for the MNPT since control samples may differ excessively from each other, particularly in the case of less responsive reagents. The MNPT should be determined with each new lot of PT reagents.
Calculation. It is advisable to have a software like Excel to make the calculations easier. Say, 20 samples are run in duplicate. The mean of both runs for each sample is calculated. Calculate the percent difference between the two readings. The percent difference should be less than 10. Exclude all the outliers that have a percent difference more than 10. In our example, one set of values shows 12.5% difference. Exclude this one. Then, the geometric mean of all the 19 accepted mean values can be calculated by inserting a simple formula on your Excel sheet. In our example, it comes out to be 11.25 seconds. Now, calculate the standard deviation on the 19 sets of means by inserting a simple formula on your Excel. Standard deviation in our example is 1.51. Geometric mean plus 2SD and geometric mean minus 2SD will give you the upper and the lower limits, or the range between which the values should lie. Hence, the upper limit is 14.27 seconds and the lower limit is 8.23 seconds. Now, look through all the mean values to see if any exceed the specified limits. Exclude all these outliers. That is, any value that does not lie within this range. In our example, these values are 16.45 and 8.15. 16.45 is greater than 14.27 and 8.15 is lesser than 8.23. Calculate the new geometric mean with the inliers. It comes out to be 11.22, and this is mean normal prothrombin time for this lot of thromboplastin. As is evident, the MNPT has been changed from 11.25 as in the previous calculation to 11.22 now. Since the standard deviation has also changed, the ranges also change accordingly. This final range, 12.32 to 10.12, will serve as the biological reference range for this lot of thromboplastin. The biological reference ranges stated in the literature are generally between 10 to 12 seconds for human thromboplastin and 11 to 16 seconds for rabbit thromboplastin. However, this cannot be used for patient reporting. Every lab is required to calculate the MNPT and the biological reference interval or range as per this above method. Once the MNPT is known, INR can be calculated by this formula. INR is equal to patient's value by MNPT value raised to the power of the ISI value. This INR value should be reported every time for each patient.
Now let's learn about the procedure of PT. PT. The test should be performed in a well-lit room to observe the clot formation. Equipment. 1. Water bath maintained at a temperature of 37 degrees Celsius plus or minus 0.5 degrees Celsius. 2. Stopwatches. 3. Automated pipettes, either fixed or variable volume, capable of delivering 0.1 ml and 0.2 ml accurately and precisely. Pipette tips. 4. Clean test tubes of dimensions 75 mm into 12 mm for clotting tests and test tube rack. 5. Thromboplastin or the PT reagent. 6. Control. This is the control for the liquiplastin reagent used in this demonstration. As is evident on the literature, control values are between 11 to 17 seconds and the target value is 14. 7. Patient citrated plasma specimens. Procedure. 1. Reconstitute the tissue thromboplastin according to the instructions. Ready-to-use reagents are also available in the market. Label the thromboplastin with date and initials.
This thromboplastin reagent is stable for 7 days after reconstitution or as written on the package insert.
Allow to sit for 10 to 15 minutes, then invert gently several times. Mix the reagent well prior to pipetting at every step in this procedure. 2. take required amount of thromboplastin reagent into a 12 into 75 mm test tube and place in a 37 degrees Celsius incubator. 3. Pipette 100 microliters or 0.1 ml of control. 4. Allow at least 1 minute for the control to reach 37 degrees Celsius. 5. Pipette 200 microliters or 0.2 ml of PT reagent into the tube containing the control. Now, why do we add twice the amount of thromboplastin? The answer is, most thromboplastins come pre-mixed with CaCl2. In case CaCl2 is provided separately, follow the instructions of the manufacturer. 6. Start the stopwatch simultaneously. 7. Mix the tubes and leave in the water bath for a minimum of 7 to 8 seconds. Then remove, wipe the exteriors, tilt back and forth gently until a visible clot is formed. As the clot forms, the mixture will gelatinize and may turn cloudy. As long as the clot is not formed, the plasma is clear and flows along the sides of the test tubes. As the clotting starts, the plasma turns turbid and the movement stops. This is why we employ the tilt tube method, as the tilting enables us to see the flow along the sides. 8. Stop the stopwatch immediately when the clot begins to form and record the time in seconds. Carry out one significant figure past the decimal point. For example, if your result is 12.23 seconds, report as 12.2 seconds. 9. In our example, the control result is 15 seconds. 10. Similarly, run the test sample. Always run each sample in duplicate whenever you run samples manually to rule out errors. For all duplicate runs, always calculate the percentage difference between the two readings. A percentage difference of more than 10 is unacceptable and that sample should be retested. The test results for the duplicate sample run are 16 seconds and 17 seconds. The average of the two readings give the final value. The normal range for PT is 10 to 13 seconds. It has to be established by each lab by MNPT. Document the results immediately. The documentation log should contain the following information: PT methodology, reagent name and lot number, ISI, MNPT and lab range values, date, name and ID of the patient, patient readings, mean and INR value. 11.
If the result is more than 30 seconds and INR is more than 2, inform it, as this could be a critical value. For several therapeutic reasons of anticoagulation, INR is maintained at a high level. For example, normal INR is less than 1.2.
Expected INR in oral anticoagulant therapy for prophylaxis for recurrent DVT is 2 to 3. Expected INR in oral anticoagulant therapy for recurrent MI is between 2.5 to 3.5. Expected INR in anticoagulant therapy for heart valve replacement is user specific. Thus, Relevant patient history is very important before reporting the PT. APTT, activated partial